This is your first overview of experimental basics. So what is an experiment? So a scientific procedure undertaken to make a discovery, test a hypothesis, or demonstrate a known fact. And you can see in this little kind of joke illustration, does anyone else have a hypothesis they'd like to test? And you can see maybe this guy in the corner has hypothesized that. I hypothesize that if I fill my shirt with ice cubes, I will begin shivering uncontrollably. So he's testing his own hypothesis. Or you might have someone saying, I just did a little experiment to test that out. And so these are examples of simple ways that we use these terms in everyday conversation. So let's lay out some of these terms in our next slide to see what we might mean in terms of scientific methods. So we have theory with a capital T, theory with a lowercase t, and hypothesis. So this lowercase theory, that's just like a guess or an educated guess we have about the reason for some phenomenon. We use this word loosely. Like, I have a theory that the reason I've been sleeping so badly lately is because I've been viewing screens at bedtime. So this person isn't contributing to the scientific foundation. They're just making a guess as to why this phenomenon is occurring, this phenomenon of poor sleep. So that's the informal way we use this word theory. If we actually form a hypothesis, and a hypothesis is a prediction about the result of an experiment to test a theory, usually it's grounded in previous research designed to test something and contribute to the science base. So I hypothesize that people who watch screens at bedtime will have longer delay in sleep than people who don't watch screens at bedtime. So you see how we've turned this loose theory, this speculation sort of, into a more formal hypothesis that could lead us to an experiment. And then the capital T theory, like the theory of evolution or the theory of attachment disorder, this is a broad conclusion that then becomes sort of put into textbooks. And it's generally drawn from the results of many experiments that all have produced similar findings. So if the findings are well supported by a number of studies, we declare it to be a formal theory. We still don't consider it to be proven because it's always possible that some study could provide evidence to the contrary. So as long as it's possible that evidence could emerge that doesn't support the theory, it's just a theory, never a certainty. We also have this lowercase experiment, the way we loosely use the word in everyday conversation, and experiment and true experiment, which we'll have at the end. So an experiment is an informal way to explore a particular phenomenon, usually without an intention of contributing to scientific knowledge. So we might say, I did a little experiment to find out which food my dog liked best. You know, it means probably we tried different foods out, but it's not designed to contribute to science. This is just testing something that's happening in our, in our lived world. Experiment with a capital E is maybe a more formal test of hypothesis that can use inferential statistics, so maybe we've actually gathered data and tested something. The researcher experimented with different levels of chemical to see which would work best, something like that. But when we come to a true experiment, which we're talking about this week, we mean a formal test of hypothesis following specific parameters to ensure that a cause-effect relationship can be established. And so we'll give the parameters in this week, and we will point out that this is the only way to demonstrate causation in the research paradigm, to demonstrate that one thing causes another thing, like this medicine causes a person to recover. To have any conclusion like that, we have to do a true experiment. So again, true experiments are the only way to demonstrate causation. By causation, we mean that one factor causes another. The medicine causes the person to recover. And that's really a function of a lot of studies that are conducted. So true experiments have two main characteristics, and we can always use these two characteristics as our litmus test of whether it's a true experiment. So first off, we would have random assignment. And what that means is all participants are assigned at random. to receive either the treatment or not receive the treatment. Every participant has an equal chance of being in either group. So don't get this confused with a similar thing we call random selection. Random selection is choosing your study participants at random from a population. That's not the same as random assignment. So don't confuse those two. And then a manipulation or treatment. The researcher must do something to the participants, like give them medicine, or give them a new method, a new exercise technique, or a new experience. But the researcher has to do something to make a difference between the two groups. The researcher isn't just measuring differences that already exist. So those are the two conditions of true experiments. In medical research, those true experiments are called randomized controlled trials, or RCTs. It might look like this. Here are a bunch of patients who have all been selected because they have some shared characteristic. They're similar to each other. And at random, meaning roll of the dice perhaps, some are assigned to treatment and some to control. Then there's some sort of an intervention, like a true medicine, and then a measure, or a comparison medicine, something that looks like the true medicine but isn't, and then another measure. And if we're comparing heart health, we can see that those with the intervention, the true medicine, had a better outcome than those with the comparison group or the control group. Treatment conditions. So experimental participants will be randomly assigned to a particular condition, either the experimental condition, and that's the condition in which participants receive the real treatment, like let's say a medicine, hypothesized to produce a particular outcome like an improvement in health. And others will be randomly assigned to a control condition, and that's a condition in which participants receive a fake treatment that seems similar to the real treatment. A fake treatment that seems like a real treatment is called a placebo. So a medicine, as in this example, the real medicine is here, and it's given to those randomly assigned to the experimental group. And the placebo is a medicine that looks like the real medicine. It might even be the same color, but it's given to people in the control group. In this example, the thing that's being measured are test scores, and the condition that's being tested is the effects of distracting sounds in the testing environment. So the people in both groups are taking the same test, but those in the experimental group have loud music in the background. Those in the control group have just normal circumstances. Ideally, we would want the situation to be very similar between these two groups, with the only difference being the independent variable, or in this case, the music. So the placebo effect is something that's always of concern to researchers, and it means that a person has a real response to a fake treatment. So in this little image, you can see one person is receiving the real drug and they experience a real improvement, let's say an improvement in mood, if that's what it's supposed to treat. Another group, the people receive a fake medicine that looks like the real medicine, and because they think they might be getting the real medicine, they too feel better. To just put that in writing, it's participants who know might have improvements based on their belief about whether they've received a real treatment. So people who know they are in the control condition where they didn't get treated, they might not expect to recover, and this expectation could impact their recovery. Likewise, people who are receiving the fake medicine but don't know it might still show signs of recovery through the placebo effect. So this would be a bias that we want to eliminate, and a way that we eliminate it is through blind and double-blind studies. So blind and double-blind experiments look like this. So single-blind experiments, participants don't know whether or not they received the real treatment, but the experimenters know. So in this example, on the left-hand side of the image, we can see this brown-haired guy is the experimenter, and the other guy is the participant, and the participant is blind to what condition they're in. They're not literally blindfolded. It just means they don't know whether they're getting the real or the fake treatment. But there's also, and that prevents biased responses like the placebo effect. But there is another concern, and that concern is that this researcher, who knows who's getting the real medicine and who's getting the fake medicine, might interpret the results differently based on his or her own expectations. And so a double-blind experiment is when neither the participants nor the researcher know which treatment group participants are in. So this experimenter doesn't know whether any one individual in the group is getting the real or fake medicine, and the participants also don't know. And in addition to preventing biased responses like the placebo effect, this also prevents biased interpretations based on experimenter expectancies. So to summarize, experiments have two key requirements: random assignment, in which everyone has an equal chance of being in either group, and a treatment or manipulation, in which the experimenter does something to the groups. Participants are assigned to one or more conditions: experimental conditions, the condition hypothesized to have some impact, or control conditions, the usual condition without the intervention. Control conditions resemble experiment conditions, often through use of a placebo, and bias is avoided by keeping involved parties unaware of conditions. A single-blind study, experimenters know but participants do not know which group, and a double-blind study, neither experimenters nor participants know which group any individual is in.